2 years in a row, Brewers are out in the first round after the regular season. You got to ask some questions. One more minute, I guess we'll go.
It's fired up the live stream, so we're ready whenever.
Okay. Well, in the interest of a longer lunch hour, let's start now. Thank you, Pete, and welcome to our Weather Watch. This will be our last one of the semester, so we will start up again. I forget the date.
Sometime in September.
Yeah, 7th or 8th or something. Sorry, 6th, September 6th. Okay, that's the next time we'll meet on a certain schedule. We may do it another time in the summer, I suppose. But it will, as I said last week, it will not be me who convenes that group. It will be someone else, and I'll gladly sit there and listen, but I'm not going to present when it comes to severe weather or hurricanes. Because everybody knows the only really interesting severe weather is winter storms. And so, you know, I mean, they have wide-ranging impacts, and they happen every 5th day, so you really have to stay on your toes. With this other stuff, it's once every 2 or 3 months. You know, you don't hear as much. Here's the last week's, I want to wait till it gets to the beginning. We always look at a week-long infrared satellite movie starting from about the time we convened the prior Friday, and here it comes, starting there. We had a pretty wild week in various parts of the country. I can't ever remember what the weather was here myself, but we had one, this is the second of cyclones in a row by about midweek, and I think then we had a period where it was relatively, no, I'm wrong. Then there was another flare-up of heavy weather down over the south central plain. So they've really, at the peak of their sort of tornado season, they've really had a lot of severe weather in the last week, so it's kind of right on schedule. And we've been talking to 100 about why. If you watch here, one after another, blow-ups. And that's because here's the Mexican plateau and here's the Gulf of Mexico, and they're at different elevations, and that makes a big difference for how the air gets curated for the development of thunderstorms. So it's really the most exciting place in the world for that. And we've had, didn't we start out this week kind of chilly? Yeah, and then it gradually warmed up. A week ago, though, one of the things Patrick and I were talking about before this morning was that a week ago today, we were expecting the whole week was going to be pretty much lost in showers and 55-ish weather for the whole week, and it was not like that. Most of the week was really nice, and more it was like this than not. So beautiful day out today, and we'll talk a little bit about the current weather, and then Patrick will tell us a little bit about the forecast. So I've got nothing more to say about this, if anybody else has a comment tonight. Okay, so let's go to the shorter term version of this, Pete. Because I'm not lost on that. I paid attention over the last day. And I told my class of 100 today, this is a great way to end the term, because look at this beautiful wrapped up disturbance here in far southwestern Ontario, just north of the border with us. Beautiful clear skies over us. In fact, there was some low level clouds, maybe even some fog in some of these places, and that disappeared quickly when the sun came up. But you can see that this storm is nicely wrapped up. We'll take a look at the 500 millibar map in just a minute. There's a pretty strong upper wave here that's sitting just about on top of the position of that disturbance, so that it's occluded. Weather Channel maps that I bring to class every day had a really long occluded front connecting back to the cold front here, and a little stubby warm front that drapes without any particular coherence across the southeast United States. So maybe we can interrogate some of the thermal fields at various places and see whether or not that makes sense. So that's storm number one. It's heavy convective weather again down over Louisiana, Arkansas, and now it looks like it's spreading into parts of southeast Texas. We'll take a look at that on the radar. Then a decent storm out off the coast of Washington and Oregon, and you can see it at this oblique angle. There's a nice clouds patch right off the coast, just invading the coast now, and then open cellular convection there on the right on the edge of the view, and that testifies to really chilly air. I'm going to guess, even though I got a bad view, I'm going to guess something like -35 at 500 millibars. For that. And then one last feature of interest for me, well, two actually, there's this cyclone. We had a series of cyclones well south of the Maritimes and north of Bermuda over the week that have had really beautiful structures to them. Almost looks like occasionally there's been a flare-up of convection around the core. And maybe a month or so from now, early June instead of early May, those will actually be real things to worry about, because that can be the genesis of a hurricane, even sometimes at relatively high latitude. Not this high latitude. But this is a nice looking storm. And then this one off the southeast coast of Greenland is also really well wrapped up, and Iceland is lurking over here. So it's kind of in the Greenland Sea. And look at all of the clearing off the coast. This is probably really cold air coming in south and to the west of this cyclone. off the ice sheet that is the island of Greenland. It's no longer up for sale, apparently. We're not entertaining buying it from Denmark anymore. But maybe that'll change by about Christmas time. I hope not. You all know what I mean. Let's go to the let's go to the radar first, and then go to the West Coast. Actually, I think the chances of that are lower than the chances of me remembering what last Friday's weather was at our first weather watch on September 6th. That's my own sense. So here's the scattered precipitation you'll see when we take a look at some of the other observations. There's a surface cold front that kind of comes across western Tennessee into eastern Michigan. And this precipitation reflects how weak that boundary actually is and how poorly organized the dynamical circulations are. And that's, I think, separate from what's going on down over the southern states. And this is a pretty decent, but not organized convection, spotty, isolated, intense convective cells. I don't know if that diminishes the tornado threat for this particular environment. I honestly don't. But it's a lot of widespread heavy rain in southern Louisiana today, and then some also in southern Arkansas. And a little bit of precipitation, perhaps back here in South Dakota. I'm not sure what that's connected to.
Places in eastern Texas have had pretty bad flooding. There's been like places with 10 inches or more.
Is that right?
Yeah.
And yesterday was the 14th anniversary of the Nashville flood, which was an utter disaster. They had 10 inches of rain in one day or something like that. And that was Andrew Winter's senior thesis project, and now he's out in Colorado changing the world with respect to superposition of jets. And that was a big factor in this particular event. So this time of year is interesting. As I've said a number of times probably, I think it's interesting because you get summertime thermodynamics. So theta E's are in the 350s down here over the Gulf Coast. And that's through a fairly deep layer. So you've got a volume of warm, moist air that you can work with. But you still can have the occasional wintertime dynamics, which are always stronger. And so you can just go crazy. Not only that, but if it gets convective, that particular event was not really fueled by intense convection of the convective instability kind. It was just strongly forced. But you can get convective instability, which may have something to do with this stuff down over Louisiana and this week's rain in Texas. Okay, so that's the broad picture over the continental U.S. Let's take a look at the surface map, though, Pete, see if we can see anything in the obs that suggests a frontal. Can we go to the one with the analyses, just so we can critique it as well as use it? It might be
like an older one.
Yeah, it might be 4 hours old or something. Oh, here's one. Okay, great. Great.
It updates it later because the front stuff comes in later.
Okay. So here's the cyclone that we saw over southern Ontario. Southwestern Ontario, thanks, Peter. Southwestern Ontario. And notice there's a pressure trough that goes all the way back across the Lake Huron. It's very difficult at a first glance to see why this front's analyzed, and it becomes stationary down over Arkansas and Louisiana further south. So it really isn't an active cold front, even by the analyst's estimate there. However, you can see a little bit of evidence for it. It's mid-60s and a few degrees warmer over Indiana and southern Illinois. Low 60s, like near Springfield. So, you know, that looks like an isolated cool spot. So it's not really a strong front at the surface. And that's not surprising. It's May 3rd. That's not particularly surprising. But it's a little bit stronger in the occluded boundary. There's a substantial dew point contrast. These are all dew points in the low 40s and high 30s, and these are all 50s. So there's something substantial about that boundary, and that coincides with the cloud maps that we saw too. So what I would do if I had the opportunity, maybe we can do this with one of the gridded data sets, is take a vertical cross-section through that and see what it looks like. Because I have an idea what it should look like if it's truly occluded, and if it doesn't look like that, then I would pass the judgment that it's not. But that's only in the half-hour analysis time that I have. Right? One would have to do more analysis than that. But that's how you start. And then it looks like there's kind of a stationary boundary here that that has a little bit of a dew point contrast too, and that's maybe what might snow in Rapid City. So that precipitation that was showing up on the radar is snowy in far western South Dakota. How do you like that, May 3rd? Okay. So let's take a look, if we could, Pete, at, before we go to the West Coast satellite image, let's take a look at the 500 millibar. Remember the cyclones here in southwestern Ontario on the surface. And the epinimous super Pete will do. Okay. So our cyclone was just about where this L is at 500 millibars at the surface. So that is sitting right on top of the 500 millibar low, is sitting right on top of the surface low. So that's really nice point of evidence in favor of an occluded type structure. Another one is, if I had a chance to redraw these isotherms, because there's no observations in Ontario, I might make this gradient a little stronger. I might make this one come back in this way and find its way back to southern James Bay from central instead of eastern Ontario. And that would give the indication that it's a bit of a thermal ridge up here. And that would be consistent with an occluded cyclone. It would also kind of be consistent with the cloud mass. So were I reanalyzing this regional part of the map, one could use the data that's here to turn that into a little bit more of an occluded looking structure. So it wouldn't be so mysterious why, even on the surface analysis from NNC, they put that. So, but before I say any more, strong, sharply curved trough, so the vorticity maximum is right about here, and so the PVA is up to sort of north of the cyclone, and that's going to drag the structure a little bit to the north and slightly to the west, back towards Manitoba. And that's not uncharacteristic of something that gets itself in this orientation. And it's a downstream ridge that's too far east for us to really be the beneficiary. We're just back behind the surface cold front here, and that's why we're completely cloud-free and dried out. Can we take a look at 700 millibars, the oft-neglected 700 millibars?
Not as oft as the 400 millibars.
No, that's right. I like that for upper fronts.
Yeah.
And then nobody else shows it, so
No.
thanks for making it. So, deep vertical structure of sitting on top of each other. So now the 700 millibar low is right underneath the 500, and they're both on top of the surface low. Again, I think this could stand to be redrawn. That's -6. I don't think that's Timmins. I forget what the station is. That's -6, but this is the -5 isotherm. So really, one could bring it even closer to that station before going away, and then I don't think there's a -10 back here, so that's about as much as you could do. But it does indicate a bit of a thermal ridge in exactly the right place, vis-a-vis the satellite movie. We don't have any of the radar from southern Canada, but I don't think it's precipitating, it's thin clouds. What about 850? So 850 is a little bit less dramatic than that, but it's often the case. I think this is what I found when I was looking at occlusions a long time ago, at least, is that the thermal structure is wrapped up at higher elevations first, before the lower ones. And that is kind of what this structure is looking like here. This is the 0 degree isotherm, and then this is the +5. So there's room to bring the +5 up into central Ontario before you come down. There's no reason at all not to do it. There may be a reanalysis reason that, you know, this computer analysis knows about that I don't. But you could make it a little bit more ridgy, but you can't make it overly ridgy. The best thermal ridge signal looks like it's between 500 and 700 millibars, which is quite interesting, but not unprecedented, at least in my experience. So anyway, a weak but pretty looking storm just to our north, and in the wake of the surface cold front tied to this whole structure, we are west of it and enjoying a really nice sunny day as a consequence with very low dew points. I didn't mention that when we were on the surface map, but we're pretty low. Can we go back to 500 millibars though? Because the feature that we're about to see on the west coast could be hotly diagnosed. It's not quite as cold as I thought. -31 is the coldest point in the analysis off the coast of British Columbia. Okay, so that's not bitterly cold, but it's pretty cold for May 3rd. And it's colder than what we have over us. So let's take a look at the West Coast satellite movie. Okay, beautiful picture, isn't it? Look at that. That's a really nice high cloud deck. It's not really got a closed off circulation associated with the clouds, but here's the cold pool, and this spacing of individual convective clouds, probably none of them precipitating. Maybe these ones back here are. This might be the heart of the cold air. Maybe it's -32 there, but it's broadly -30, and that's good enough with +10 for the surface temperature. You got a 40-degree temperature difference over about 5.5 kilometers, so that's moist unstable. It's about an 8-degree lapse rate. It's easily going to be moist unstable, so that any of these saturated updrafts are freely convective, and then the surrounding subsidence just gives you the spacing. So this has always been my theory, and I know I've said this a million times, but AI could prove this. You could actually, I think, do this. The spacing between these cells should correlate with how cold the 500 millibar temperature is over a fairly uniform ocean surface, because the stronger the convection, the free convection, the more intense the downdrafts, and the more widespread they have to be. Actually, in a stable environment, they got to spread themselves out to do it. So I contend that you'd have bigger spacing if it's colder, and each of those clumps will be more intense. And that goes hand in hand with this picture, because these are less, we get a better view of it from this angle than we did when it was on the oblique side of the sphere. These are not very large and they're kind of speckled. They're really close together. That coincides with not so intense instability. And then the last thing I wanted to say about this animation was, look at this moisture plume. Here's the state of Hawaii. So this is the boundary of the northern subtropics right about here. And so even though we can't see all the way past the date line, one gets the impression that this cloud mass and thereby presumed moisture plume emanates from at least the northern subtropics, or well past the date line, Central Pacific, and comes all the way up to Kodiak Island. And it's getting involved in a development over here. And then you can see a little bit of a swirl in the southern Bering Sea that looks like it's got some structure to that, and it's organizing this whole big circulation. So that's interesting. That looks more winter-like than spring-like to me, but it's there nonetheless. Could we try to look at a cross-section through, I can't remember, is it pivotal or tropical tidbits?
Tropical tidbits.
It does the cross-sections best. Yeah, and let's see if we can get the 850 millibar temperature, and we'll go to a slightly bigger region. We might just be out of the range there. Maybe North Atlantic works, Pete, because it is over here, so let's see if that gets us there. And then, can we get 850 millibar temperature? It might be under thermodynamics. I don't know if it's even available. We'll try with thickness then. Height and wind, but not temperature. Okay, well, we'll pull a fast one. We know that 1,500 thickness will work too in well-developed storms. That's the one we use in our analysis, so because it spans a deep part of the lower troposphere. This one is a fairly shallow structure, is my guess. But let's try cutting a line right like that.
You want it,
Actually, right here, right along that
you
one.
want the left side of the top or the bottom?
It doesn't matter. We'll be able to tell when we see it. In a way, the reason I'm asking for this line, I can see a little bit of a thermal ridge in the thickness field right here. And so I'm trying to draw perpendicular to that axis of that thermal ridge in that location. So let's see what this will work, theta E. So let's see what theta E looks like.
So the left
Oh, a
is the
little bit,
north.
yeah. So when we're right at the top, closer to A, right? Yep, look at this. Here's a bunch of moist isotopes that maybe are the cold frontal portion of this structure. There's a big plume of ascent, and then here's the less steeply sloped collection that are maybe the warm frontal part of that. So this does look like it's occluded, and so maybe the clouds that are there are tied to the ascent right in the trowel, and Portia's thinking about that for her continued work. So it's a nice little structure for a fairly weak storm. So these are ubiquitous structures. They happen all the time in the life cycle of the extratropical cyclone, and if you look with some experience and maybe a little bit of finagling, figuring out the best way to draw them, you can really pull that structure out. Look at that axis of maximum theta E. It's unmistakably there, right? Between the cold front and the warm front. Exactly like what you might expect. And the vertical motion plume is right in the middle. And I don't believe it's forced. Prior research has shown that some of the forcing anyway, or predominant amount of forcing for that vertical motion has to do with the wave scale, PVA by the thermal wind, as one example of wave scale, not so much the frontal forcing. Then Phil Schumacher at Sioux Falls at the Weather Service said, why don't we abandon the quasi-geostrophic assumption and see what the real frontogenesis looks like? And that does give you a picture of a little bit more frontogenesis along the middle and upper tropospheric part of the cold front. This orientation of vertical motion makes me wonder if that isn't the thing that's driving this one more than the PVA. The other factor is this storm is not any longer developing, so there may not be any strong PVA anymore. Although the vorticity structure is pretty strong, as we saw at 500 millibar. So it's always a can of worms. Candy worms, you know, the kind you like to eat when you're in kindergarten. So it's fun to get into it and see if you can't figure it out. And we got a little bit of insight on this one. Boy, that theta E ridge comes all the way down to the ground. Right there. You can't miss it. Okay, that's all I have for the current weather. So Patrick, as always, gives us really excellent forecast. There's bound to be 2 or 3 new websites that he'll unveil.
Only one today.
Only one.
Yeah.
Remarkable. So that means on the order of 20 for the term.
Right. Could I start with the AOS forecast page, please? So the development of that trough feature that's off the west coast is very interesting, so I'll be taking a look at that. If we go back one quick, I'll use this one, please. And then 6 hours at 500 is what I'll start with. So we get a sense of the trough ridge pattern at 500. So first, this is roughly midday, so roughly what we saw. First, here's the trough forcing that, slight precipitation out over South Dakota, Nebraska. Some of that snowing, but this is the feature I want to focus on. So first, you can see we're sort of in this pattern where we have a ridge over the eastern side of the United States. This is a weak trough. Here's our next weather maker. And it will be a weather maker in all senses. Winter weather, severe weather, normal rain, and I'll prove that to you by showing its evolution. But you can see it's almost poised to, barrel straight into the west coast. These are almost straight north-south, sort of north-south, flow associated with this trough. It's nicely wrapped up. It's single, two contours around itself, and then you can see nice vorticity on the backside of this. So we'll watch this evolution, and this is what I'll be tracking here. Could we get the surface map from this same time, 6 hours? And again, this is midday today. What's interesting about it is you can see it's associated with a thickness minimum, meaning that right in the center of that cyclone, there's very cold temperatures. We saw that, Professor Martin showed that very nicely, but these are well below freezing if you take the thickness lines to correlate with snowfall. And this is barreling right into the western coast of the United States where you have topography. So we'll watch this. This is actually going to produce snowfall over the western United States, and it's May.
528 is the critical thickness in Seattle. It's about
Right.
the 50-50 line, and that's at the core of this thing.
And this is 524.
Yeah, so it's...
And we'll watch this evolution. But, it's picking up on the snowfall and, whatever scattered mess that is, and the precipitation along the cold front. And out ahead of it, you can see a low pressure developing, and the thickness is recovering from what they were earlier on the week. You can see the nice thermal ridge that has been bringing us the spring weather in the 70s. So if we could go a day ahead, 30 hours at 500. So here we see exactly as we predicted, this whole feature is moving on to the western coast of the United States. The vorticity is strongest right on the bottom of this trough axis, and so anytime you have that, you're going to have decent PVA about the thermal wind, very nice divergence. You have a nice trough ridge couplet, so you can expect very strong ascent. It's really cold, as we showed, and you have mountains. And so that's all going to conspire to produce, some of these locations will get a foot plus of snow for May 4th. And then we'll see a complete opposite effect once it passes the mountains here. But I'll show, can we go to the surface at the same time, 30 hours. So here it is. It's still associated with very cold thicknesses right in the center. And all of this, most of this is probably picking up on the terrain, along with down here at the bottom where it's stronger ascent, stronger precipitation forecast. This is that PVA of the thermal wind at the base of that trough. Some locations near the surface might even get some snow from this. It's hard to tell what the thickness might be right on the coast and if there's interactions with the sea, but definitely some snow for the western part of the United States. Out ahead of it, we are under a high pressure, so we begin to warm. And you can see that, the thickness ridge building right downstream of where it's really cold. So that's setting up the stage for some potential severe weather going forward.
That little blob of intense precipitation on the Oregon-Washington border is right...
Oh, yeah.
It's right about where Mount St. Helens, Mount Rainier are.
Exactly.
It almost makes you think that they know where the mountains are.
It might.
And this resolution, I would be surprised.
Mount Shasta, too,
Yeah, that's
and
right. Yeah.
Lake Tahoe. So I have no idea if the GFS knows that there are mountains there, but it probably knows that there's increased terrain.
Yeah, no,
at
it's
least.
amazing.
Yeah, good point. So if we go 24 hours now ahead, 54 hours in the forecast, this will be Sunday now. And so here we begin to see inklings of what's ahead. So we see vorticity still strongest on the base of this trough. It's rounding the mountains. Out ahead of it, you have a ridge. So you are undoubtedly warming the surface out ahead of this trough feature. Synoptic scale ascent is still over the mountains, but you can imagine as this progresses, into the middle part of the country, you have forcing for ascent. It's warm, it's moist. Here's your severe weather setup. And I believe Sunday is the first day they actually have some severe weather highlighted for the middle part of the country. And then I'll show Monday as well. Both of these days look particularly potent for severe weather in areas that do not need more severe weather, as we've seen. And it's producing snowfall, so snowfall and then tornadoes. Same system, same part, same country, just, 600, 700 miles difference. Pretty remarkable that this is happening. It happens all the time.
It's American meteorological exceptionalism.
Yeah, absolutely. Yep. Absolutely.
No place like this country when it comes to that.
So if we could see the surface, please, Pete, 54 hours. And I'll show you this here. So here we have maybe this is midday, so you can imagine storms might fire up in the afternoon, but you can see the nice thermal ridge building out ahead of that trough. Here's a surface low beginning to form. This is all presumably still snowfall, especially in the mountains, but the 540 line, the typical rain snow line for sea level areas around sea level, big bullseye of really cold air, Northern California, Northern Nevada. So snowing, severe weather out ahead of it, one single system. And we are in high pressure, so we're gonna have a couple days of nice sun, nice warming. You can tell that even though we've had forecasted days of 50 degrees, you get sun and easily hit 70 degrees this time of year. And so now, if we could go back and show 24 hours more in the forecast at 500 first, so 78 hours. You're good, no worries. Here it becomes interesting. So this is a intense trough feature. The values here are almost 8 times the Coriolis force. So that's how strong this vorticity strip is. It's very stubby. Out ahead of it, you can imagine a lot of synoptic scale ascent due to divergence. You have a ridge still downstream of this trough. So right where we've already had severe weather, right where they had decently strong tornadoes, eastern Nebraska, western Iowa, this looks like they're in the gun for another day of severe weather on Monday here.
Good thing nobody lives in Nebraska.
Nobody lives in Nebraska. Yeah. Right, exactly. There's only 1 billion videos of all the tornadoes that happen from the no people that live there. And I can say they're beautiful because they didn't, no loss of life, at least for those tornadoes. But if you're watching this and you're cleaning up from tornado debris and then you see this, you're thinking, oh crap, here we go again. We go to the surface, same time, 78 hours. Here we already begin to pick up on some precipitation developing out ahead of this low pressure system that might have, it's a broad low pressure system, but you have very strong flow from the south, straight from the Gulf, warm thickness. So Sunday into Monday, looks like another bullseye for the middle part of the country.
Well, I'm surprised at the lack of development at the surface in western Nebraska. Maybe it's just beginning at this time?
I think it is, yeah, we'll see that. This seems to be the main feature that will develop.
Yeah, that's a really strong thermal contrast there, and it's coincident with the vortex max.
Exactly, and look at how strong the thermal wind would be.
Yeah, right.
Right where we saw that vortex max, so very strong ascent right in the central part of Nebraska. This is where nobody lives. But, eastern Nebraska, western Iowa, that's where all the people are. Yeah, yeah. And then I'll show one more time, 24 hours further from this one. So 102. And then once that, feature is very tightly packed, it loses its coherence. We're just in a big trough feature now over much part of the country. We get under the influence of some rain starting Tuesday and into Wednesday, but I won't show Wednesday, I'll just stop here. But luckily for us, that feature falls apart as it's so strong in the central part of the United States and sort of loses its decent structure as it moves towards our region. And we're just under general troughiness, as is most of the western part of the United States here. If we go to the surface at this time too, we'll see we begin to get under the influence of some rain. Thicknesses fall on the backside of this low, but this is 979 now. And I believe it does form, some portion of Nebraska into South Dakota and then move northward as this whole thing develops. So a substantial cyclone out of this trough feature, and we're just under the influence of some lighter precipitation, it looks like, for Tuesday, and then this holds into Wednesday as well before we get back into sunny conditions. So Sunday into Monday, central part of the country, I'm sure we'll have more videos of tornadoes. At least, it seems like every single day for a week now we've had videos of tornadoes and just massive destruction, which you know, it happens, you just have to be prepared for it.
And it happens now, I mean, it's right on schedule.
Exactly, exactly. And then if we could go to the weather.gov page. Perfect. Could we refresh this? So here's winter weather advisories for May, high wind warnings and watches for that system as it's barreling on the coast, and then we have flood out in Texas where we saw a lot of heavy precipitation. And then what I want to end on, if we could search, this will be my website, last website of the calendar year. We could search CPC space CFS. And this first page, I believe. Yes, okay. So this will be a look at wishful forecast for 3 months going into the future. If we could go to this 2-meter E3. So here's a look as what we should expect for summer, very accurately from the CFS model. The trend is what I want to highlight though. So we can look at different trends here. This is May, June, July, August, June, July, September. I'll just focus on these 3 right here. What we can see is La Nina beginning to develop over the equatorial Pacific. You can notice that by, these are temperature anomalies at the surface, but it shows up in the sea surface as well. When this happens, typically, we see warmer conditions for the eastern part of the United States and colder for the western part of the United States. We kind of see that signal. Most of the eastern portion of the United States is expected to be anomalously warm. That signal does, you know, spread to the western portion of the United States as the summer progresses, but the trend is we are expected to be warmer than normal throughout the summer from this one run of the CFS. And then one more thing I wanted to point out from this is, I don't know what this is over the Amazon and in Brazil, but this little warm anomaly shows up and persists for a long time from what I've seen. So I don't know what this means, but you can see it's a pretty intense, robust feature that persists for a while. It's persisted in a lot of the runs of the CFS model. I don't know what it is, but that's another bullseye to look out for potential impacts for weather. Luckily not in our region, but over South America as well. So warm for the summer. That's your official forecast. Anything anybody wants to see before we
Just
break?
the North Pole for
Yeah.
September, October, November.
Yeah,
It's
even
like-
Antarctica too.
Yeah,
That's
Yeah.
your Arctic amplification on display.
yeah, exactly, yeah.
And then, Patrick, another thing to note is
Mhm.
that with the La Nina, you have the tropical region of the Atlantic is also warmer, and I think that's pretty consistent. So
Oh,
that
yeah.
has implications for hurricanes.
Oh, I was gonna say, it's already record warm, and
Yeah.
you have anomalies even warmer than what currently is. This is reading in current data, and then progressing it forward, so, yeah, good point.
I also wanted to share that last night there were some really impressive sun shafts, and I think the roof cams, the west room,
Really?
yeah, roof cam picked it up pretty well.
What are those?
Just like the sunset,
Oh,
just like the
there's
sunset.
sunbeams.
The clouds yesterday were really,
Yeah.
Yeah,
it was
very
a lot.
dramatic, yeah, it was a dramatic conflict.
very pretty.
There was a rainbow yesterday morning too, a red
Oh, really?
rainbow.
Oh, yeah, the red one,
Yeah.
yeah.
I didn't see that.
We can go back and I'll show you. It's like 8 in the morning.
Maybe, might be going too fast, but I wonder if that was,
Oh, some sun pillars.
oh,
Is that what it was?
After, once it gets closer to the horizon, you'll see some very sharp.
Yeah.
Very nice.
Nice.
That's cool.
Yeah, they were pretty quick.
Oh, yeah, son of a gun, look at that.
Nice.
Oh, wow, neat. Wow.
this one loop has a lot of things on it.
Yeah.
Kind of wavy clouds yesterday morning too. I don't know.
Yeah, the apparatus kind
Yeah.
of went in there.
North Alabama.
Yeah, north of them, yeah.
Yes.
And then it's the south, which is the storm to
Well, by all means, if you see something interesting, I can't watch these like all day, every day. That's really cool. But if you see something interesting on the rooftop cameras, let me know. I can, make a better, higher quality loop. Because these are reduced to 1024 by 768 resolution, but the original camera was like 4K. So
Oh, wow.
I can go back and redo those and put them up on YouTube in 4K if there's something worth looking at.
That sun pillar might be,
Yeah, right, catching
Yeah.
one of them
yeah,
right at the
that
right
was the
moment.
new website picture.
Yeah, right, on calendar.
Yeah.
That's really cool.
Here's when, we had storms in the morning, I know,
Oh, yeah.
so this must be those.
I'd love to just look at these all day, every day.
Me too, yeah.
Put on a
Really
good
fun.
music soundtrack.
Yeah, you can see the thermal wind sometimes,
Yeah.
you know,
Oh, yeah.
in different cloud layers.
So you can see some lightning there, very quickly.
Very
I
cool.
do have some playlists on the
the sheets
YouTube
of rain
channel.
is so cool, so
Yeah.
that is awesome.
If you look at
Virga.
Virga, Virga, yeah.
Oh.
Yeah, very nice.
Anything anybody else
Hot
wants to
Monday.
see?
All right, thanks,
All right.
Patrick,
Yeah.
thank you, Pete.
Another great year of weather watching.
Yeah,
folks.
yep.
I also want to note that there's cookies in